Hello everyone, and today we are looking at electricity and magnetism, or electromagnetism, because they are in fact the same thing or different expressions of the same force. And there's a lot of power in that force, as we can see evidenced by the lightning in the background, one of the most powerful natural forces we know. So let's just briefly review what is in the atom. Inside the atom, we've talked previously about three different things which basically make up the atom, and if you remember those and what charge they have, the first one is protons. Protons have a positive charge inside the atom. Then there are electrons, which have a negative charge inside the atom. And the final thing that makes up atoms are the neutrons, and they have a neutral charge, which means in the most part we don't end up talking about them. In fact, what we mostly talk about are the electrons, because the electrons are the outermost part of the atom. They are really the part that gets involved in the passing along of charge. So most of what we talk about will focus on the electrons. Funny that, electrons having something to do with electricity. So, what actually is charge? Well, we're going to say that charge is a fundamental property of matter, and as such there is no more fundamental things that we need to use to make up charge. It just has charge. And the effect of charge is to decide the way that an object will react in an electromagnetic field, or when placed under an electromagnetic force. And the greater the charge that is carried, the greater the effect of that force. So as we saw in the previous slide, charge can in fact be positive or negative, and charge is measured in a certain value, and that value is coulombs. Coulombs are the unit of charge, but in equations we represent charge with the letter Q. When we investigate charge in the atomic level, we see that everything exists in quantized units of charge. We have mentioned this before as well. The elementary charge has a value of 1.602 times 10 to the minus 19 coulombs, and obviously for an electron that will be negative 1.602 times 10 to the minus 19. So this is the charge that is carried by electrons, but also protons, and with negative and positive cancelling each other out, that means the overall charge when you have the same number of electrons and protons is 0. The value for the elementary charge, you may remember, was discovered by the American scientist Robert Millikan. So, we've thought about what charge is, so let's next go on to ask what is electricity. So we know that electrons have a negative charge measured in coulombs, and electrons move around a circuit. That is how electricity is carried, and they will move from negative to positive, because negative charges repel each other and opposite charges attract. So just a note there that when you really get right down to it, the actual thing that causes electric force to be passed comes down to the transfer of photons, but we're not going to go to that level of detail. So before we move on, let's just think quickly about the idea of a conductor and the idea of an insulator. So you may know that things that carry electricity are called good conductors. And why do we call them this? Well, because the free electrons in the structure pass the electric charge through it. If you know about the periodic table, you may know that the metals are in the middle, and this means they have partly filled electron shells. And this means that they are more able to share their electrons and pass them around, and they're not too desperate to hang on to them, but they're also not too desperate to get rid of them and react with anything. So that is why the metals make good conductors. On the opposite end of the scale, there are insulators, and they are not able to pass charges well. So, overall, electricity is what we call the movement of charge around some electrical path, and that path, you may know the name for it, is called a circuit. So when electricity goes all the way around from an initial negative point, and the electrons are pushed away from this, and at the other end there is a positive point, and the electrons move towards this. That is a circuit. And so the movement of the charge around a circuit is a phenomenon called electric current. So current is what we're going to move on to next. So in an equation we give electric current the symbol I, and as we said, that is the amount of charge flowing through the circuit, and we measure it over a given time. So, thinking about our previous equations, how do you think this is going to be calculated? Well, if you guessed that the relationship between charge and current is divided by time, then congratulations, you've correctly recognized a rate of change. So you have I, the current, is the amount of charge Q per unit time t. So just like speed is distance over a unit time, current is charge transferred over a unit time. So let's think about defining a current then, shall we? We have measured current as the amount of charge passing in a unit time, and we have given the symbol I as current in equations, but I itself is measured in units of amperes, which have a capital A as their unit. So what 1 ampere means is 1 coulomb of charge passing through a circuit every 1 second. So how many electrons would this be? Well, if you take the number of coulombs per second and divide it by the number of coulombs on an electron, you end up with a very, very large number, and that is the number of electrons that will be passing in a given second, a point on the circuit. But there's a lot of electrons, so that isn't actually very fast in absolute speed. So let's start bringing this into the real world a little bit, and you may recognize these, and these are called cells. And you might know them as batteries, and that is an everyday term, and I will use it quite happily. But if we're going to be technical, these are all individual cells, and more than one cell connected together, as we often do, then that is called a battery. The battery is the repeated nature of the cells. So, what is it inside each of these cells that allows us to get some kind of electrical effect? Well, what's inside is all a different bunch of chemicals, and so the energy inside is chemical energy. However, when you connect the battery or just a cell to a circuit, then that changes into electrical energy. So this is again just a transfer of energy, like every other effect in the universe. So, when a battery is in a circuit, electrical energy is carried by the electrons as they move around the circuit. So it can be converted into other forms of energy in the different components, and that is how an electrical circuit is able to do work, by converting electrical energy into other forms of energy through its components. But in actual fact, as we said before, the electrons do not move very, very fast at all. The reason that when you switch on the light goes on instantly is because all of the wire is full of electrons, and so as soon as you start to put energy in one end, it will come out the other end, because the transfer of the electrical energy does happen from one point in the circuit to another at the speed of light. So how fast do the electrons actually move around the circuit? Well, it's in the region of 10 to the minus 4 meters per second, so that's about 1/10 of a millimeter per second. Again, thinking about circuits, how do we measure current in circuits? Well, electrical current is measured with an ammeter, and that gives you a value in amps, and this can be connected at any point into the circuit, and if we just have a simple circuit with one electrical path, it will read the same at any point around the circuit. So, the amount of energy that is given to an electron at any point is called the potential. And so the potential is the way that electrical energy is carried around the circuit. So they can have different potentials because energy can be used in different parts of the circuit. So when you measure potential, you actually measure a difference in potential, the difference in the potential of electrons from one side to the other of 2 points in the circuit. So you might not have heard the term potential difference before, but there is another name for it which you certainly will have heard of. However, we're going to leave that until the next video.